All right, here's some level 3 tips and tricks for you with squares and equilateral triangles, and then we're going to take a look at triangles on a coordinate plane. Get us used to what we call the unit circle. So, in squares, remember a couple different things with squares. If you have a square, we all know that a square, hopefully know, that they have all equal sides. Okay, so that means that I have right angles in the corners as well. And then if I draw in a diagonal, what happens with the angles? What happens with the right angles? Well, I hope you know that they got cut in half, they got bisected, which means each angle is 45 degrees. So within a square, when you draw in a diagonal, you create two 45, 45, 90 triangles. So that will help you. You'll have problems that deal with the perimeter and the area when you're just given that diagonal, or if you're just given a side length, you'll be asked to find the diagonal. So you can use a 45, 45, 90 shortcuts in order to do that. Okay, last trick here, you've got equilateral triangles. That means all sides are going to be the same, so they're all going to be equal. That also means all the angles are going to be equal. So if I have a triangle with all equal angles and there's 180 degrees in each triangle and 3 angles in them, that means each angle is 60 degrees. Okay, so if each angle is 60 degrees, and then if I want to maybe draw in a height of one, that means this is 60. Here's my 90-degree angle. That means that other angle is going to be 30. So within equilateral triangles, when you split them in two, you create two 30, 60, 90 triangles within them. Okay? So just something to keep in mind as you're working through problems in your packet and for your homework. All right, your unit circle. Something we're going to talk about later in a couple weeks, what this unit circle is all about. But if we can understand 30, 60, 90 triangles, this is going to be a lot easier for us to deal with, okay? So if we have this coordinate of h, we want to find where it is. H is going to be at the end of this point. If the angle is rotated 120 degrees, so we're always starting from this kind of like home base. So we're going to rotate it 120 degrees. So I want to make you aware that this is going to be 90 up here, this axis. Okay, this is going to be 180 because it's a straight line. This one down here is 270. And then this one, if I come all the way back around, is going to be 360 degrees. Okay, so if I have 210 degrees, that means I'm somewhere in this quadrant, in the third quadrant. So if I take my 210 degrees that I rotated, and I want to find out how much space is in between this line that I drew and the axis that makes 180 degrees, I'm going to take 210 minus 180. So that's going to give me 30 degrees. So that means there's a 30-degree angle inside there. Okay, so if I draw a triangle with the 30-degree angle, and I want to find the location of this guy, I'm going to use the most basic form of those 30, 60, 90 triangles. So here's my right angle. So remember, in my 30, 60, 90 triangles, okay, if this was a 30 and here's a 60, this was x, this was 2x, and this was x root 3. So very, very similar to that, but I want even more basic. Instead of x's, I'm going to write 1's. So this is 1, 2 times 1 is just 2, and then 1 root 3, or just root 3. So I'm going to use the most basic form of this when I'm working on the unit circle or the coordinate plane. So across from 30 is going to be 1, across from the 60-degree angle is root 3, and then this is going to be 2. But if I'm looking at the coordinate of this point, I need to know how far over it goes and how far down it goes. So how far over, that's the x-coordinate, is going to be root 3. But since I'm going to the left of the origin, that's going to be negative. And then going down, I'm going to go down 1. And yes, the length of the triangle is positive, but where this point is, it's going to be negative 1. Okay, let's take a look at another example of those, because I know those can sometimes get a little confusing. So again, we want to find the coordinate of h if the angle is rotated 315 degrees. Okay, so, whoops. So 315 degrees. That means this is going to be 90. This was 180. This is 270. and this is 360. So somewhere this 315-degree angle is going to lie somewhere in this fourth quadrant. Okay, so either I want to find out this angle back to home or this angle to 270. I don't really think it matters, but let's do both to see what makes sense to us. So I'm going to take 360 minus 315, and that's going to give us 45. Whoops, not 44. 45. So that's this angle right in here. Okay, and then I'm going to do the same thing. I'm going to take 315 and subtract 270 to find it out back to that axis. So 315 minus 270 is going to give me 45 degrees again. Duh, because it makes a right angle. So I have 45 degrees in there, so it really doesn't matter where I draw the triangle. I'm just going to draw it back to the home one. Okay, so that's 45 degrees. I need to know where this guy is down here. So I need to know how far over and how far down. So if it's a 45, 45, 90, just like the 30, 60, 90 that we talked about in the above problem, we want the most basic form. So instead of saying x and x for those two side lengths, we're going to say 1, 1, root 2. So this is going to be 1, 1, and root 2. But if I'm saying those are the lengths of the triangles, but if I'm calling them coordinates, I'm going to the right 1 to get down here, so that's going to be a positive 1. And then if I'm going down to get this other point, that's going to be a negative 1. So while the lengths of the triangles are positive, the locations of the points also could be negative. All right, one last thing in level 3s is talking about maybe hexagons or different types of pentagons or polygons. So in a hexagon, those are 6-sided shapes. So if I draw my 6-sided shape, okay, so here's my hexagon. They're all going to be equal. So if I have a perimeter of 90, I'm going to divide that by 6 to get the lengths of each side. I'm going to get it to be 15. So each side length is going to be 15. And if it asks us to find the area of the pentagon, I've got to find a couple different things. Now, I don't know exactly how to find the area of the pentagon, but here's my tip to you, is that you're going to start in the center and you're going to break this up into 6 different triangles, and they're actually all going to be the same triangle. So if you find the area of one of them, you just multiply by 6 to get the area of all of them. Okay, so how do you do that? Well, let's start with drawing in the height, and that will cut this bottom in two equal parts, so 7.5. Okay, well, let's think about this. Is there a way that we can find out the measure of some of these angles in here? Well, within those dots, it looks like I kind of made a circle. So here's a circle, and if I divide it by 6, 1, 2, 3, 4, 5, 6, I can find the measure of all those different angles. So 360 divided by 6 is going to be 60. So that's the measure of each of these angles in here. Well, when I drew the height in of this triangle down here, I cut that angle into 2 equal parts. So those are 30 each, which makes this one a 60. And hey, look at what we have. We have a 30, 60, 90 triangle. How funny is that? Okay, so now that we have a 30, 60, 90 triangle, we can go ahead and find this height out. And we really don't need the hypotenuse here. We just need to find the height to find the area of the triangle. So if this side length is 7.5, the height is going to be 7.5 root 3. Okay, based on our ratios, our proportions. Okay, so 7.5 root 3, you can leave it just like that. So now if I'm going to go ahead and find the area, I'm going to take the base. Remember, it's the whole base. So 15 times 7.5 root 3 and divide it by 2. So that's going to be the area of just one triangle that I'm outlining here in red. Okay, so I took the whole base of 15, multiplied the height of 7.5 root 3, and divided by 2. So 15 times 7.5 divided by 2 is going to be 56.5 0.25 root 3. So that's the area of one triangle, and since there's 6 of them, I'm going to multiply it by 6 to give me a grand total of 337.5 root 3. Okay, so that's just another application of finding area of polygons.